Today we're going to talk about product attributes. This is an important topic because it's the language of product performance and product development. Before I jump into the key takeaways, when we think about an attribute, for a product like a car, it's kind of straightforward, right? None of us really need to have worked in the car industry. We can probably all rattle off an attribute or two of a vehicle. I know there's a lot of truck owners here, so when you think about a truck, you talk about your payload capacity. It's measured in pounds. You talk about your towing capacity. It's measured in pounds. You talk about your fuel efficiency. There's a measurement, miles per gallon. How many people? Do you have 6 or 5? So it's pretty straightforward. With the sealer, it can get a little bit trickier, not so much just getting the high-level performance attributes, but what is the test and what is the right way to measure that? And when you dive into it and you get a little deep, all of a sudden you find that maybe you're measuring one thing that's a little different than what you started off on. So today is going to be sharing with you our current knowledge and understanding of the way we think about the attributes, what the test is, and how we measure that. Because if we can't measure it, then it's a little tough to make it better. So what is an attribute? Well, it ought to have 3 elements. Number 1, it ought to describe product performance. Number 2, it ought to be of some value to the customer or the consumer. And number 3, as I mentioned before, you got to be able to measure it. So we're going to jump into the attributes that we've decided are important for the sealer, and we're going to walk you through the attribute, the test we use, and then how we measure that. So here's the list you guys have been waiting for. There's a lot of performance attributes up there that should look familiar. I'm going to run through them top to bottom here. Dry time. Very complicated test we have. It's called the dry time test. Release to traffic or cure time. Also, top secret test, the dry time test. In both cases, folks, they both have to do with basically the removal of water from the system, right? And the difference between those two things is the amount of water that has left the system. Dry time is really that moment that you can get on top of that surface and put a second coat down or put the stripes down. It is not cure time. You may not necessarily want to have a pickup truck pull into that parking stall and turn the wheels at 0 speed. The system may not be ready for that torsional abrasion. Cure, we think about now enough water has left the system that you actually have either a tough enough system that it resists abrasion, or you may have a mark, but it's self-healing with a little heat and time. You won't see that mark in a couple of days. So we have a test, and to be quite candid, it's the one test that we think is unique enough. We think it's proprietary. So I won't get exactly into how we measure the minutes, but at the end of the day, it is what matters, I think, to a lot of folks here. How long does it take for the system to get to what we would call dry, and then how much longer still for it to get to cure? Enough about the products. Those are the 3 products. Back to the attribute. Actually, tackiness is the next one, so we talked about that a little bit. We use a cool little test called the Zapon. It's an ingenious little test. It's ingenious because it's so simple. We literally heat up a sample, stick a little element to it, and how fast that element falls off tells you a little bit about whether you've got a tacky. And so a low number is good. You want to put it on there and just have the thing drop off. And this is a sample that we've heated up. Tim's going to talk about a lot more of these things in depth, by the way, in the next 2 days. But we get that thing heated up nice and hot to a point where if you're not prepared for it, you're going to have a sticky sample. Durability, that's obvious enough. To date, we've really been using the wet track abrasion test. I think a lot of you are familiar with it, those of you who are in the slurry business. It's a modified version where we strike a sample on a piece of tar paper, wear the abrasion. Again, you're going to see pictures of this later. Again, low number good. How many grams of loss do you have on your sample? We're using that as our measurement for durability. And so I think we've just started doing a lot of work around permeability. In the end, I can see durability being, it's the persistence of color, impermeability, and friction. And we're working, I'm not sure if we were able to get the machine down here, but we're working closely with a company called Instratech. We're in the development stages with a brand new testing machine that'll help us, rather than wearing a tar paper with our stuff on it, we're actually using slab compactors, creating a true slab of hot mix asphalt, applying our material, putting it through wear, and then testing for a lot of these attributes again. Tim found a test where in the lab we can actually judge the degree of blackness. So has a system got less black? We've done a lot of benchmark testing. I'm going to share some of those results with you here in a moment. But when it comes to color, we can actually use this scale, and it's like a light absorption test. And if you're pure black, there's no, it absorbs all light. And then at the bottom, for our applicators and the guys that are licensees who are responsible for making this stuff, right? This is the stuff that is really important to you guys. Is it storage stable? Can you transport it? Can you put it in a mixed tank for 1 week or 1 month? Can it go through a filter basket without losing its aggregate or other components of the mastic? And then pump stable. Can you pump it without the shear of the pump breaking the material down and either, again, problems you'd be worried about is losing your aggregate dropping out, or just through shear segregating your mastic, and you don't get a nice homogeneous film on the pavement. And so these are the attributes. There clearly are other attributes. There may be even other ones that are important we talk about, but these are the ones that when we do a new formulation, you've got to pass the test on these. So the question is, how do you determine which is most important? Well, we've talked about it a little bit. We focus on those that drive a competitive advantage. We did a pretty comprehensive benchmark study on some common competitors. I say common. These are, for most of the markets, these are what we hear from our account managers and our licensees. These are, in most cases, the most prevalent customer we're up against, whether it's Texas or Missouri. These are parking lot sealers, by the way. We wanted to be ready for this symposium, and this was not easy to put together, but clearly compared to the on-the-road products, this was a better way to try to get this study put together in time to present to you lovely people. And so what you see is the black line is Axis C1M3. Onyx would perform pretty similar to this. C2 would not, by the way. C2 at 60 degrees Fahrenheit and 85% relative humidity, C2 would not be a top performer at those conditions, which is why we don't recommend doing C2 in the shoulder season. The other thing about this is in an environmentally controlled oven, which means it's dark, there's no sun, which means the pavement or the surrogate for the pavement temperature is identical to the ambient. So you have 60 degrees on the pavement, 60 degrees in the air, 85% humidity, and then Tim went to great lengths to build a chamber around it so that the air wouldn't even flow through the chamber. So this is also zero wind speed. We're pretty proud of our performance. Not only that we're the fastest, but what is really interesting is you look at the slope of ours, it's pretty well linear, right? Which means whatever rate we're doing, Axis is presenting water to the surface at a pretty consistent rate so that air can do whatever it does. That's the same for any sealer, right? The sealers differentiate one another by how fast they present water to the surface as they set. Once the water's on the surface, you guys can all go out to the internet. You can find the equation for water evaporation. It's based on 4 key variables. And I'm talking about once you just have water on the top, you have the air-water interface. It is the surface temp, which is the pavement temp. If you guys have an IR gun, you can shoot it and know that number. It's the air temp. Look at your phone. Everyone has air temp. Wind speed and relative humidity. If you know those 4 variables, you can plug them into equation and you can know to the minute how fast a puddle of water of any given size is going to dry. And so the race to drying fast and curing as well is how fast that system can move the water out into the surface to be wicked away. I'm not sure if you guys paid attention to the second best performer in that dry time, but I thought I'd go ahead and share you the wet track because that's our durability surrogate. You know, if you want to dry fast, you can just start with a sealer that has less water. You can put a lot more solids. The thing about solids, right, anyone who's been in the business long enough, solids typically cost more than the water. So what kind of solids are you putting into your system? I don't know for the competitors, but if something dries really fast and we measure the solids and has much higher solids, and then we look at the wet track, and basically that score just means everything was gone. The wear device just shot right through the tar paper and was rubbing metal on metal by the end of it. Makes you question. Oh, sorry. Good. Thank you, Tim. This is grams of material lost. And so, you know, we have what's the thickness of the sample? Yeah, so there's not a ton of material there. For any of you that have seen our Onyx guideline, and we'll get into it, we have an 80-gram maximum loss as a product guideline. And so you see us down there at 19, and there's some other guys that perform well on this test. What? Yeah, low. Sorry, I'm not getting into what Tim wants. A small bar is a good bar. Thank you, Tim. La la la, I'm the VP of technology and little people. Sorry, I'm an idiot. Thank you, Tim. Anyhow, again, we're proud of C1M3. Onyx would most likely perform pretty similar to this as well.